Okay, this video is going to give you a little bit of insight into some of the algebraic rules that we can apply to Boolean functions. Okay, and the first one that I want to make you aware of is double negative. Okay. When we negate a Boolean variable, first of all, a Boolean variable is what we've been using, what we've been calling something like P or Q, which can take on a truth value, either true or false. Okay, can be true or false, and in our notation here so far this semester we've said that P is an element of the set 0, 1, and so is Q. Okay, and when we negate a Boolean variable, we simply invert it. So if I make a little truth table for P, then P has two possibilities, either 0 or 1. If I negate it, then it just flips them both to the opposite. Okay. If I do a double negation, it flips them right back. And so a double negative is logically equivalent to just removing both negation signs. Okay, P is equivalent to not P, and anytime we want to write not P, we can just eliminate both of them and actually skip writing the double negative. We often skip that step, and if we have to negate something that's already negated, we just write the original variable. Okay, so the first one is the double negative. Okay, and these are included in the handout that I gave last week. The next one is De Morgan's rules. These come in a couple different formats, but basically there are ways of turning ands into ors and turning ors into ands. And the De Morgan's rule, the first one, is that if we put a negation sign around P and Q, that is, whatever P and Q evaluates to, we negate that quantity. That is equivalent to not P or not Q. Okay, so on the left-hand side we could say it's not both of them. That is, not both of them are true. And on the right-hand side, it says that basically that one of them's got to be false. Either P is false or Q is false. And you can see intuitively, I hope, that that's the same thing. Saying that they're not both true, not both P and Q are true, is the same as saying at least one of them's got to be false. Okay? And it seems it's kind of easy to remember. Basically what you do is you reverse the sign, you negate everything, and you change the and into an or. So we're going to negate the entire statement. We are going to negate the P and we're going to negate the Q. And we change the and into an or. Let me show you that this is true by making the truth table for this De Morgan's rule. So I'll make a P and a Q, and I'll make a place for P and Q, and I'll make another column for not P or not Q. And I'll go ahead and set up my truth table. I will ask this semester that everybody sets up their truth table the same way, starting with all zeros at the top and ending with all ones at the bottom. Okay? And this will give me an opportunity to show you a technique for doing the truth tables. Okay, First of all, I'm going to write down the truth values for P and Q, right here, P and Q. And I'm going to write those truth values in this vertical column right underneath the and sign. And then I'm going to negate that column, and I'm going to negate it right under the negation sign. And it's going to be this column, this final column, that gives me the truth value for the entire statement up here. Okay? And so on the and function, it is true only when both of them are true. And so the only time the and function is true is in the very last row where both of them are true, where both P and Q are true. Otherwise, it's false. Now I'm going to negate this. I'm going to turn all the zeros into ones and all the ones into zeros. And what I'm going to do is I'm going to circle this column to indicate that this is the column that finally evaluates to the thing up at the top. The other column was just some scratch work, essentially. I'm going to do the same thing here, and this is a technique that you should learn for truth tables. I'm going to put a column over here for not P. I'm going to put a column over here for not Q. And then I'm going to look at these two columns and do an OR between them and fill in the final result right down the middle. So P has a pattern of 0, 0, 1, 1. 0, 0, 1, 1. So the pattern for not P is going to be 1, 1, 0, 0. The pattern for Q is 0, 1, 0, 1. So the pattern for not Q is going to be 1, 0, 1, 0. So I can fill those in. There's the negation of P. Here's the negation of Q. And when I do an OR step between the two, the only time the OR is false is when they're both false. So I'm going to put a false down here and then trues up here. And similarly, I'm going to go ahead and circle that one because that is the final answer for this. And you can see now that that De Morgan's is true based on this truth table. Okay? So that's one form of De Morgan's. Another form of De Morgan's is as follows. If we put a not sign in front of an P or Q, you know what, I'm going to go ahead and erase this. Okay, and I'll make it a little bit smaller here. Right. If we have a not out in front of a P or Q, then that is equivalent to not P and not Q. This is one you can also think about. So there's the first De Morgan's, here's the second De Morgan's. You can think that this is intuitively true because it says it's not the case that either P or Q is true. That means they both have to be false. And that's exactly what the right hand says. It says P is false and Q is false. I'll leave it as an exercise for you to prove that this one is true, also using the truth table technique that I used up above. Okay, I'll stop there for this video.